Hey guys, we are moving on to 2.3, which is the product and quotient rule. So you guys have learned the power rule. We learned the long way to do derivatives, which is with limits. Now we're going to learn how to derive a function which can be separated into two separate functions. And here's what I mean by that. So the product rule is applied when we can separate one function we see into two different ones, and they're being multiplied. To find the derivative of a function like this, you would multiply the first function, just regularly, by the derivative of the second function, and you would add it to the second function, just normally how it's written, times the derivative of the first function. And that's where this notation comes from. It's the first, so f of x, times the derivative, g prime of x, plus g of x times the derivative f prime of x. And you'll see it more clearly when we start to apply it. Be careful that you cannot find the derivative of both f of x and g of x separately and then just multiply them. That does not work and will give you the wrong answer. So here is one example. It says find the derivative of h of x. Now, I know we can go ahead and FOIL this problem and just use the power rule, but sometimes it takes longer to do that. So here's the steps that you would have to take. We separate our two functions. You can label them as, let's say, f of x, and g of x. And just like it was written above, you take the first function as it is, and multiply it by the derivative of the second function, so the derivative of 5 plus 4x. Then you add that to, reverse it, the second function times the derivative of the first. So now actually taking the derivative here, the derivative of 5 plus 4x is just 4. And for the second part, the derivative of 3x minus 2x squared is 3 minus 4x. Simplify, combine your like terms, and there is your final answer. Make sure that when you write down the final answer, I don't think it does it here, you actually need to write out the notation. H prime of x is equal to blank. Key thing to keep in mind, which was a mistake on some of your quizzes, if the function is given as h of x, you need to use that same h of x notation in your final answer. You can't change it to f of x or y. Okay. Learning the quotient rule, and then we'll apply both. The quotient rule is applied when you see the division of two functions happening, and you can't simplify it, so you would have to use the quotient rule. That implies that you would take the original denominator times the derivative of the numerator. That's what this is right here, g of x times f prime of x, minus the numerator times the derivative of the denominator, so f of x times g prime of x, all divided by the denominator squared. No derivative over here, just the denominator squared, where g of x cannot equal 0. So here's an example of two functions being divided. We can say y is equal to f of x over g of x if we want to apply the definition. To find the derivative here, the denominator is x squared plus 1 times the derivative of the numerator, that's what's going on here, minus the numerator itself times the derivative of the denominator, all divided by the denominator squared. Now when we scroll down and simplify, to actually find the derivatives, that's what you get. Simplify further, and simplify as much as you can. If you see something where you can factor and start canceling, you can do that, but usually it's just combining like terms and leaving it as is. And don't forget that notation. So I think in this problem, they give you the original as y, so when you use notation, y prime is what you need. Okay, like I said earlier, if it's easier to simplify and then take the derivative, do it. If you find it easier in this problem right here to FOIL and then use product rule, that's fine. But let's go through product rule for this problem. So to find the derivative, or f prime of x, here are our functions, f of x and g of x, or we should call this h of x so we don't get confused. We take the original first function, x squared plus 1, times the derivative of the second. So what's the derivative of the second function? It's just 7. Plus the original second function times the derivative of the first. So times 2x. And then simplify that. This becomes 7x squared plus 7 plus 14x squared minus 6x. Combine your like terms and you get 21x squared minus 6x plus 7. There would be no need to try to factor here. You're not trying to get zeros or solutions or factor. You could leave it as is. And I forgot one thing, which you should never forget, the notation, f prime of x. Okay. Number 2 has a little trig. Be careful to separate these functions. It's x cubed, which is separate from cosine of x. So f prime of x would equal the original first function times the derivative of the second. The derivative of cosine x is negative sine x. Plus the original second times the derivative of the first. Be careful here. You don't want to combine the derivative inside the cosine function. So it's 2x squared. But we want to put that in front so we don't make any mistakes here. When I clean this up, I also want to be careful with this negative. It comes out in front of the x cubed, sine of x, plus 2x squared, cosine x. And hopefully you saw the mistake. It should be 3x squared. And that's your final answer there. No factoring necessary, nothing to simplify. Try these 2 examples on your own, and then, all right, so here are your final answers for y prime for number 1, and here's y prime for number 2. You might have tried to simplify or factor out an x. There's nothing much you can do there. So just to kind of review that, when you're simplifying, sometimes you can clean things up. Sometimes you really just need to leave it as is. So if you look at this chart of examples, notice how when you clean it up, there's no factoring involved. It's really just combining like terms, simplifying things, canceling out. Here again, distributing things, combining like terms. The only slightly different one is this one right here. If you have anything like that, you want to continue as far as you can go. So if I continue this problem, it becomes sine squared of x minus cosine of x plus cosine squared of x. And we have that over sine squared of x. Now the sine squared x plus cosine squared x is just equal to 1. That's an identity. So it's really 1 minus cosine of x over sine squared of x, which is what we have here. So sometimes you need to use your identities to kind of condense a problem a little more. We are now going to try some product rule problems. Try this problem. Find the derivative of y using the product rule. All right, here is your final answer. If you have any questions, make sure you circle it and bring it up in class.